So following on from the previous video, we got to this stage here where we're trying to understand why this equation will yield this graph. So rearrange this. That will then take you to here, and then square root both sides. When you square root both sides, you're going to get a positive version and a negative version. Positive and a negative. Bear in mind that this is an even function. So anything happens on one side, it will happen to the other side. Well, look at the domain for this. When will this break down? You see, the other one was this, x squared minus 1. The other one breaks down because this bubble here will be negative in this region. But if you look at this, x squared plus 1 looks like this. It will never, this bubble here will never break down. So the domain for this would be everything in the real number line. Whereas this one here, it breaks down between negative 1 and 1. So the domain for this will well, nothing really breaks down. That's why you can go through from negative infinity to positive infinity. And then when x is 0, when x equals 0, this thing here would be 0, 0 plus 1, square root of 1 will be 1. So that's why the intercept is 1. And then think about what happens when x gets very, very big. Take the limit as x tends to infinity. As x tends to infinity, this one here is going to be negligible, so we can just ignore this one here. So as x heads towards infinity, this bubble here will act as x squared, and then you've got your square root. So you can think of this as being like x. So as x gets bigger and bigger, you're going to have it's going to look something like this. So this is your y equals x graph. It's going to look something like this. So you're going to have some sort of asymptotes along there. And the same argument can be used when x take the limit as x heads towards negative infinity. So you're going to get something like this. So as x heads towards negative infinity, it's going to look like this. So overall your graph will look like this. Okay.